Algebra 1 students, welcome to your 5.5 notes. Today we're going to look at the standard form of line. We're getting a little bit deeper into the idea of graphing lines and what the different forms look like. We looked at slope-intercept form, we looked at point-slope, and now we're going to look at standard. So the standard form of a linear equation is ax plus by equals c, where a, b, and c are all real numbers. And you can't have all of them equal to 0. So although standard form isn't quite as nice as slope-intercept or even point-slope for that matter for graphing, we can still use it. In most cases, there are some exceptions, but in most cases you can use standard form to graph. So here's an example: 4x plus 8y equals 16. Essentially what we do is we find our two intercepts. If you plug in 0 for x, that means you're finding the y-intercept, and you can see the math there. Plug in 0 for x, you get 8y equal to 16, and then y would equal 2. If you plug in 0 for y, this is when y is 0. That gives you your x-intercept at 4 and 0. Now the nice thing about this is we know it's a line. We have 2 points. All we have to do is graph those 2 points and connect them, and you have a line. So we'll take a look at that process a little bit more in depth, but we'll start with something a little more basic, just simply finding the intercept. So let's start on number 1. It says to find the x and y intercept. So we'll start with the y-intercept. That's where x is actually equal to 0. So I'm going to do 4 times 0 minus 5y equals 40. And of course 4 times 0 is just 0. So I'm going to divide both sides by -5. And I would know that my intercept is at y equals -8. By the same token, I can plug in 0 for y. This will give me my x-intercept. And actually, if you think about it, if I'm plugging in 0 for y, I'm just not going to write that term. 4x equals 40. Sometimes I even like to just take my finger and cover up that term that's not being used, and then just look at it this way: 4x equals 40. So we know we have to divide both sides by 4, so x then would equal 10. All right, continuing on, number 2, let's take a look. It says -2x plus 9y is equal to 10. We essentially have two equations to solve. One of them is if y is 0, we'd have -2x equal to 10. The other is if x is 0, then 9y would equal 10. And in both cases, you can just simply divide. So x would be -5. That is your y-intercept at -5, 0. And then your y-intercept would come from dividing here. So y then would be 10/9. Now if you think about these as just intercepts, we've done the job. If you would rather think of them as ordered pairs, it'd be like -5, 0, and 0, 10/9, something like that would do the trick. All right, why don't you pause the video and give that a shot on the next two, 3 and 4, and then compare your answers to mine. All right, welcome back. You can see my work on numbers 3 and 4. One thing I want to point out on number 4, you'll notice that we just had one y, so I didn't actually have to do any division. I could quickly find the intercept. Y is equal to -16.5. So that's again the point 0, -16.5. Let's continue on. Now we're going to take that process one step further. Instead of just simply finding those intercepts, let's go ahead and graph them. So I've got two equations I can get from this. 5x equals, excuse me, I wrote the wrong number there. 5x is equal to 10, and -2y is equal to 10. Again, these come from if I plug in 0 for y, I'd have 5x equals 10. If I plug in 0 for x, I'd have -2y equals 10. A little division quickly tells me that x is equal to 2 and that y is equal to -5. And here's how easy it is to graph this. X equals 2, y equals -5. Now remember, again, these aren't ordered pair, or these aren't linear equations, I should say. They're actually ordered pairs, like this: 0, -5, and 2, 0. And once you have 2 points, you can just simply connect them, and you'll have yourself a line. Pretty straightforward method. All right, again, why don't you pause the video and try number 6 on your own and see how you're doing. All right, you can see my work on number 6. There were a lot of negatives in there, negative 4x, negative 8y, negative 32, but anytime, as you know, that you take a negative and divide by a negative, you get a positive. So x equals 8 and y equals 4 were the two key points, or two intercepts that we had, and you can see what the line would look like. All right, let's change gears a little bit and go away from standard form and go back to what we know about vertical and horizontal lines. I've got a little reminder over here on the right. Remember this, the Hooyvuk's thing. Some of you know that well. Some of you might want to get that thing figured out, I'm thinking. So here we go, graph the line y equals negative 4. I'm going to do these really quick. I'm going to just underline the color I'm using. There, that one's in blue. Y equals, that's horizontal, negative 4. 1, 2, 3, 4. Horizontal line. Boom. Done. There it is. All right, let's try another one. X equals 5. I'm going to use red this time, and you can see the X, the Vux part of this comes into play. So vertical lines have an undefined slope, and they're always X equals some number. In this case, it's 5. 1, 2, 3, 4, 5. And there is my vertical line. How easy and quick is that? Okay, again, pause the video. Do 9 and 10 on your own and do them right. Okay, you got those right, right? Well, anyway, here's mine. Number 9, x equals negative 8. That's this vertical line in green that you see right here. 10 was a little tricky because it's y equals 0. That throws us off when it's like 0. Where's that? Well, y equals 0 is another name for the x-axis. So it's essentially just this purple line. It's kind of hard to see, but it's right here on the x-axis. All right, one more little topic for us to look at, changing into standard form. So we're starting in something other than standard, and we're changing it. Now, a lot of times, not starting in standard means that we have fractions involved. We don't like having fractions in standard form because we only have integer values. So what I'm going to do is multiply both sides of this equation by 3. I'm going to go ahead and rewrite that. 3y equals 7x minus 6. Now to get to standard form, remember standard form, ax plus by equals c. I essentially just need to subtract 7x from each side. So negative 7x plus 3y equals negative 6. Now some people, and including your textbook, I believe in this, aren't big fans of having a negative out in front, so they may want you to multiply everything by negative 1 and make it 7x minus 3y equals 6. Myself, I'm not a stickler on that. If you want to do this, that's great. If you're okay with a negative up front, negative a term, so am I. All right, number 12, we're starting in, that's right, point slope form. You're already thinking it, right? So y plus 8 is equal to 3 times, and we're going to distribute this, 3x minus 15. Again, I need to move the 3x to the other side. And some of you may have been saying, well, hey, how about moving that 8 first? And I think you'd have a good point. That would be a good idea. Negative 3x plus y plus 8 equals negative 15. So we do need to subtract that 8 from both sides. So negative 3x plus y equals negative 23. Again, you could feel free to multiply everything by 1. You'd have 3x minus y equals 23. And that would be a really good way to write that, but so is this. All right, we have one more slide. Now this is an on your own slide. Give these two a shot. They're pretty similar to what we saw in the last two. See how you're doing writing things in standard form, and pause the video now. All right, folks, welcome back to the last slide. Here is my work on number 13 and also on number 14. Again, I gave you on 13 alternate versions. Either of those is completely acceptable and fine. Hey, I hope you guys picked something up today. This standard form is something that we'll be using from time to time as we move forward here. I want you to be comfortable graphing it. So, you guys get those notes finished, fill it out, and the class ready to work. You guys have a spectacular day.